Okay, so we're gonna do, so before school ended, we did speed, distance and speed. So how we calculate speed?
Distance over time.
Okay, distance over time. Okay, and then if I'm given a distance time graph, how do I calculate the speed?
Divide it into two shapes.
Sorry,
Divide it into shapes.
divide it into what?
Shapes.
Okay, yes, correct. Now, for that is for if I have a graph and I want to find the distance, then I do area under the graph. But if I have a distance time graph, then I must find the gradient. I must find the gradient between 2 points. That is the one where, remember, we draw the triangle, and then I take a point here, point here, and then I minus and divide. Do you all remember? Yes?
Yes.
Okay, so that is for to find speed. I look for the gradient under the graph. Okay, so do you all have your textbooks with you?
Yes.
Okay, so we are going to be looking at page 21. Okay, can you all go to page 21?
Ready, sir.
Okay, Minian, page 21, okay?
Yes.
Rehat, okay? Nicholas, okay?
Yes, sure.
Okay, if you don't understand or you can't hear me, make sure you say. Okay, now, so we're going to look at
Sure.
understanding acceleration and then calculating speed and acceleration. Okay, so if we look at speed, right? Speed is basically, you want to see how fast or how slow you're going. So let's say you're driving a car and then you start off with maybe 60 kilometers an hour. And then you want to go faster, you go 120 kilometers an hour. That's like really fast, and then you keep going fast, right? Okay, that is speed. But then if we look at acceleration, we are looking at between a given time, what is the rate of the speed that is changing? What is the rate of change of the speed? So let's say I start with 60 kilometers per hour. And then slowly I increase my speed and I go to 120 kilometers an hour, let's say. So we want to find the rate at which the speed is changing. That is acceleration. Okay, I repeat, speed is distance over time. So for a given distance, okay, how long do you take? And then you get the speed. So for example, I'm going from here to let's say KLCC, okay? And let's say Lohindra takes 20 minutes to go, and then Wingyan takes 30 minutes to go. So who goes faster? Lohindra is faster. So Lohindra definitely used a higher speed because he reached faster. So that is speed. Okay, when we look at acceleration, in the speed itself, how much it has changed. That's what we're looking at when we look at acceleration. So acceleration is okay, we're looking at how much the rate at which the speed is changing. Change of my speed over time. Okay?
Yes.
Okay? So my change in my speed, right? Okay, in this case, change means when I take my final minus my initial. Let's say I go from 60 kilometers an hour to 180 kilometers per hour. So what is my change? My change is
180 minus 60.
160. So my
180
final,
minus 60.
correct. So if I,
120.
right, so I take my final minus my initial. Okay, but okay, one thing we have to change here is we don't use speed. This is terminology. We don't use speed, but we use velocity. Okay, why do we use velocity? There's a difference between speed and velocity when it comes to terminology. Okay, when we look at speed, it's just magnitude. It's just 20 kilometers an hour, 60 kilometers an hour, 100 kilometers an hour. But then we're looking at velocity, we're looking at direction. 20 kilometers an hour heading north, 50 kilometers an hour heading south. So we look at acceleration, change in velocity. So my acceleration can be a negative as well. Okay, my acceleration will have a negative and a positive as well. Okay, so when we're looking at acceleration, we're looking at change in velocity divided by time. So my rate of change of my velocity. Does that make sense?
Yes.
Yes.
Okay, can you just quickly copy this down? This one and this one. All done? Mehak, done?
Teacher, I just connected back. What did I miss?
Where did you go off? What was the last thing you did?
Where the last thing we did was the 180 minus something.
Okay, so why I'm taking 180 minus 60 is because change of velocity is basically my final velocity minus my initial velocity. That's why I
Okay.
change, and then divided by the time taken for the
Okay.
journey, for that journey lah. So 20 minutes or 30 minutes or whatever. So let's say I start with 60 kilometers per hour, but then
Yes,
I
teacher.
end 180 kilometers an hour. That means to find my change in velocity is I take my final, what I stopped with, my end of journey speed, end of journey velocity minus my starting velocity. Does that make sense?
Okay, teacher. Yes.
Okay, so just quickly copy it.
Okay, teacher.
I'm grass.
Are you enjoying this whole quarantine thing?
Ah,
Are you
very
enjoying
boring.
the quarantine thing?
Very boring, sir.
Learn how to cook lah. Your mother at home ah. or not? Working.
Yes.
At home also.
My mom at home.
Okay, Mehak, are you done?
Yes, teacher.
Okay, so with acceleration, right, the formula is this, okay, and usually we have symbols for it, okay. So final velocity we put as v, initial velocity we put as u, okay. So v minus u over time will be t lah, and acceleration we use a, okay. So which means acceleration equals to v minus u over t, final minus initial divided by t, okay? Okay?
Can teacher.
Yes.
Okay, so final velocity minus initial velocity. Velocity is similar to speed, it's just that it has a direction. So speed will usually be in meter per second or kilometer per second or centimeter per second, usually meter or kilometer lah. Okay, and then time is, let's say if it's in second, so acceleration will be meter per second, so meter per second square. Understand? So speed is
Yes.
meter per second, acceleration is meter per second or m/s square, because speed is already in meter per second, and then time is another element of time here is second, so it will be second square. Does that make sense?
Yes.
Okay, so now my speed, right, can be meter per second, can be kilometer per second also. Depends lah. Okay. So if let's say it is v minus u over t, let's say this is in kilometer per hour. Okay, and then time also, let's say hour. So my unit will be kilometer per hour square. It just depends on what unit is being used. If let's say one is hour and then one is second, when I divide, what do I do?
Change the second to minute.
No, one is hour, one is second. And I want to divide it, so what do? I have to have the same unit. I cannot be having kilometer per hour per second. There's no such thing.
Or change the kilometer per hour to meter per second.
Okay, you can change the hour to second, or you can change the second to hour. Either one. Okay? You can also change the second to hour. Then your answer will be kilometer per hour lah. Understand?
Yes.
Yes.
Okay. So make sure when you divide, right, it is in the same unit. You know, you'll get a different answer.
Yes, sir.
So quickly just copy this one. One in the box. Done?
Yes, sir.
Yes.
Ian, done?
Yes.
Okay, so just now, right, when we add distance over time, and I have a line, how do I find the speed?
Gradient.
Sorry,
Find the gradient.
I do the gradient. So I draw a triangle, and then I find the gradient, correct?
Yes.
How I get speed.
Yes.
Okay, so now, similar case, if I have a speed and time graph. Okay. Just give me a moment. Okay, so now if I have speed and time graph, okay, how do I calculate the acceleration? For distance time graph, to calculate speed, I do a gradient. For speed time graph, if I want to calculate the acceleration, I do the, what do I do?
Find the velocity.
Okay, so basically I'm doing this, which is also finding the gradient. Because let's say I have a velocity here, correct? My starting velocity is here, my ending velocity is here, correct?
Yes.
So V, so this will be my V value, this will be my U value. So V minus U divided by, this is the time lah. V, this is 3 seconds and then 4 seconds. 3, 5. So my time is 2 seconds. 5 minus 3, 2. So I take V, let's say this is 10 meters per second, this is 8 meters per second. So
2
V minus
2 meters per second.
10 minus 8 divided by 2 seconds.
1
2 divided 2 is 1 meter
1
per
per
second.
second square.
1.
Okay, so basically
Yeah.
the speed time graph, and also for acceleration, I calculate the gradient. For distance time graph, to calculate the speed, I find the gradient. Speed also the same thing, because speed is distance over time, correct?
Yes.
Yes.
So this is 10 meter, and let's say this is 6 meter, and then this is my time. So let's say 3 seconds and 8 seconds. Okay, so speed is distance over time. So my distance will be from here to here is 4. And then my time is 5. So it is 4 over 5 meter per second. That is my speed. So basically it's calculating the gradient lah. Same thing here for speed. So every time you do a graph, right? You have a graph. The first thing you must do is you must check what graph is it. Is it a distance time graph or is it a speed time graph? If it's a speed time graph, okay, acceleration is finding the gradient. If it's a distance time graph, the gradient will give me
Speed.
the speed. If it's a speed time graph, the gradient will give me the
Acceleration.
acceleration. So you have to be very careful what graph they give you. Okay? And then if we look at distance time graph, the one earlier Lohinga mentioned, you divide it into sections and then you find the area. What am I finding?
The area under the graph.
What is area under graph?
The speed.
No? Speed.
No, not the distance. Distance.
I'm looking at the total distance
The
covered.
distance.
Okay? Understand?
Yes. Yes, sir.
Yes.
It's the same thing for speed and time. When you calculate the area under the graph, you divide it into shapes and then you divide it. When you find the area under the graph, we are looking at total distance covered. Understand?
Yes, sir.
Okay.
Yes, sure.
Okay, so just to recap.
Hi, my heck. Hi, my heck.
Hi.
Hi.
Bye lah.
Okay, so very quickly, for distance time graph, Okay. So my gradient will be, what am I looking at?
Speed.
Speed
For this
or distance.
area,
Rate radial height. Area under graph is total distance.
okay, this is for distance time graph. If it's speed time graph, gradient is,
Distance.
no, for speed time graph, gradient is
Acceleration. Acceleration.
and my area under graph is
Acceleration. Acceleration.
gradient is acceleration. Area under graph,
Speed. Total distance.
same is total distance. So if you look at both distance time graph and speed time graph, for distance time, you remember distance over time is speed. So the gradient is speed. For speed time graph, speed divide time is acceleration. So the gradient is acceleration. For both, the area under the graph is total distance. So you only have to remember the difference. The area under the graph is the same for both. Total distance, total distance. Distance time graph is speed. Speed time graph is acceleration. Can?
Yes, sir.
Quickly copy. Okay, Dana.
Yes, sir.
No, sir.
Yeah, still doing.
Done.
Okay, done. Okay, that is actually all for today's class. Next week we will do again on Zoom. We will do chapter 3. Okay, chapter 3
Okay,
is
sir.
question. I will put up some questions for this part of chapter 2 lah. Okay, so please do Okay, Ken?
Okay, sir. Yes, teacher.
Okay, Lohindra, okay, Nicholas, okay.
Yes, sir.
Any questions?
No, sir.
Okay. Okay then, bye.
Right, sir.
Bye.